Hi, let's solve a problem of weekly contest 239. The problem name is minimum adjacent swaps to reach the kth smallest number. In this problem, basically, you are given with a number and an integer k. Now, you'll call a number as wonderful integer if the permutation of its digit is greater than the number itself. Only then you call a number as the wonderful integer. So, for example, if this is the number given to you, then after permuting its digit, this will be the next wonderful integer of this number. That is a number whose permutation is just greater than the original number. So again, this will be the next and we stop at k. So this is the kth smallest wonderful integer for the original number. Now you need to return the minimum number of adjacent digit swaps that needs to be applied on the original number to reach to this kth smallest wonderful integer. This is the question given to you. Now, before moving to the hint of this problem, I would suggest you to please pause the video once, try it on your own, and then only move to its hint. So now I hope all of you have tried this problem on your own. Now let us solve this problem together. So basically, in this problem, we want to reach from the original number to kth smallest wonderful integer. So to reach this kth smallest wonderful integer, we also want to reach the first smallest wonderful integer, then second, then third, and so on till the kth. So basically, we want all these numbers to be in increasing order. Only then you will be able to find the kth smallest wonderful integer. So this is the first point we have got. So now we can easily conclude that we want the numbers to be in increasing order. They should be the permutation of each other. That is, we want to find the next permutation of the number that is just greater than the number. Again, the second will be the next permutation of the number which is just greater than the first wonderful integer, and so on. So our problem has reduced to the point that we want to find the next permutations to find the kth smallest wonderful integer. So let's take an example to understand this. So let's say the number that we have is 1, 2, 5, 4, and then 3. And we want to find its next permutation. So if we want to find the next permutation, then we should always think of the place having lowest place value first. That is this number. Why? Okay, so is this the next permutation of this number? No, this is not just the next permutation of this number. That's why I'm saying that we should always think of the place having lowest place value first. Now, let's start moving from the lowest place value. Let's start moving backwards from this 3. What if we swap this 3 and 4 with each other? Let's try to do so. So we have found that this number is smaller than the original number itself. This is not even a wonderful integer. So this means this is not the next permutation. Okay, then let's try to swap this 3 with 5 again. 1, 2, 3, 4, and then 5. Is this the next permutation? No, again this number is smaller than the original number. So this is not the next permutation. So now let's try to swap this 3 with 2. Okay, so if we swap this 3 with 2, we'll get this. Yes, this number is greater than the original number itself. So this can be the next permutation as this is a wonderful integer. But let us check, is this the next permutation? Okay, so if we observe carefully, then this is the number which is the greatest number starting from 1, 2. Now, if we have replaced this 3 with this 2, then we have found a number which is the greatest number starting from 1, 3. Now we want to find the smallest number starting from 1, 3 to find the next permutation of this number. To do so, just reverse all the digits behind it. So we'll reverse all these digits and we have found the next permutation of this number. Now the question comes, how we got to know that we have to swap this 3 and 2 originally? How we have found that we shouldn't replace this, we shouldn't swap this 4 and 3, we shouldn't swap this 5 and 3, but we should swap this 2 and 3. So to do so, while moving backwards, we'll check whether the numbers are in increasing order or decreasing. If the numbers are in increasing order, until that point, we can't swap the digits. Because if we keep on swapping the digits with the lowest place value, then we'll get a number which is smaller than the original number. As soon as you get a digit which is in decreasing order, as we have found over here, because we know that 4 is greater than 3, 5 is greater than 4, but 2 is not greater than 5, then we'll swap this 2 with the lowest place value, that is 3. And we have found this number. After that, we just have to reverse all the digits which are present in reverse order. That is, we have to swap all the digits in increasing order to decreasing order. So this is the next permutation of this number. So I hope you got till this point how to find the next permutation of any number. Now in the given problem, we want to find the kth smallest wonderful integer. That means we want to find the kth smallest next permutation of any particular number. So this means you need to apply this process of next permutation k times on a number. So this is how you reach from the original number from the kth smallest wonderful integer. So we have completed the first step of our problem, that is to find the kth smallest wonderful integer. Now what is the next step of our problem? The next step is we need to find the minimum number of adjacent digit swaps to reach from the original number to the kth smallest wonderful number. So let's take this example only. This is our original number and this is our kth smallest wonderful integer. Now we need to find the minimum number of adjacent digit swaps to reach from this number to this number. Now let us see how we can do so. Let's take a new page. So our original number was 54893555142. And the fourth smallest wonderful integer that we want to have is 54893555421. This is our fourth smallest wonderful integer that we want. Now we want to find the minimum number of swaps that are required to make this original number equal to this fourth smallest wonderful integer. So if we traverse both of these numbers, let us start traversing them. We can see that 5 is equal to 5, 4 equal to 4. So we traverse both of these numbers. 8 equal to 8, 9 equal to 9, 3 equal to 3, 5 equal to 5, 5 equal to 5. Oh, but this 1 is not equal to 4. That is, we are having a difference at these two digits. That is ith digit and jth digit. First of all, we'll find the point where both of the string are mismatching because the number of I is not equal to the wonderful integer of j. We have to find this point at the first side. Okay, after finding this point, we want to make both of these numbers to be equal, right? So let's find in the second number, where is the original number that we want to be placed over here? We want 1 to be placed over here. So let's try to find 1 in the second number. So let's traverse the second number further. So for that, we'll keep on incrementing a j until number of I is equal to wonderful integer of j. Okay, so let's increment it. For now, we have 1 and 4. They are not equal. So let's increment j. So are they equal now? 1 and 2? No, they are still not equal. Let's increment our j further. So now the number of I is equal to the wonderful integer of j. We have found the same number. What do you want now? We want that this 1 to be placed at the same position as that of I in the original number. So you keep on making adjacent swaps with this j until we'll reach to the same position as that of I. That is until I is equal to j. Till that point we'll keep on making the swaps. Let's see how we can make those swaps. So for that I am just erasing all these things. Okay. So now first of all this was our j. The first swap will be this 1 and 2 because we can only make the adjacent swaps. So let's make the swap. So after doing this swapping, we'll see that we'll have our 1 over here and 2 over here. Along with this one, our j will also move to one step backwards. So this will be our j now. So can I say that our I is equal to j? Still, I is not equal to j. This means we have to make one more swap. Okay, let's make the swap again. This will be 1 and now this will be 4. Along with the 1, our j will also move one step backwards. Can I say that our I is equals to j? Yes, now our I is equal to j. Then we need to stop over here. We have brought our 1 at the original position. In a similar manner, we need to do the same for the rest of the string. But in this example, we have found that we only need to place 1 at its correct position and all the swaps are done. But you need to do the same thing for the rest of the string so that you can place every digit to its correct position. So in this manner, you can count the total number of swaps that you have done. So over here, we can see we have done a total of 2 swaps. First of all, we have moved 1 from this position to this and then this position to this. In 2 swaps, we have got from our original number to the kth smallest wonderful integer. So now I hope you have got how to proceed in this question. First of all, we need to find the next permutation. You need to do it k times to reach the kth smallest wonderful integer. After that, you need to find the minimum number of steps to reach from the original number to the new string. So now I hope you could proceed with this question on your own. So thank you.